in this lesson, we are going to discuss making a graph from a set of data. Now, we had a little trouble with this in our pre-test. Hopefully this will clarify a lot of things up. So let's get started. First, we have our data set right here. We have our volume and our mass. Now, we have these different points, and they are correlated. So 2 milliliters has a mass of 5 grams. 4 milliliters has a mass of 10 grams. You might even be able to see some of the relationships or correlation there, but that will become more apparent later. First off, let's start with making a scale. And what we're really doing is we're finding an amount per unit. Essentially an amount per box. So we look at our data, and our x-axis and our y-axis, we have to figure out which one's going to go where. Now, in this case, our volume is our independent variable, and our mass is our dependent variable. So you want to write that down here. So we're going to have our volume on our x-axis and our mass on our y-axis. So I don't want to jump ahead, but if you look down here, it's important that we have units and labels. So we have our mass, and it's important to write what unit that is. We have to know if it's in grams or kilograms. There's a big difference. Normally you want to write that in parentheses next to the axis title. And volume is in milliliters. So let's do our volume first. So our x-axis, we need to figure out what increments are. So to do that, we have to count the number of boxes that we have here on our x-axis. We have 1, 2, 3, 4, 5, 6, 7, 8 boxes in our x-axis. So if we want to find our unit per box, well, we look over here and we have a range of 12 milliliters. That's our largest volume. So we have 12 milliliters per 8 boxes, and that's equal to 1.5 milliliters per box. Now, it's fine to do that scale, so every point on the x-axis, every line would represent 1.5 milliliters. Sometimes we don't like to do that because half might be difficult for what we're doing, but what you can do is you can always round up. Rounding up will work. And if you get a very small decimal, that would help too. Round up will make sure you fit all your data. So let's round up to 2. So each box is going to be 2 on the x-axis. So this line will be 2, and we'll have 4, 6, 8, 10, 12, 14, 16. Now let's do it for our y-axis. Now, we have 30 grams as our largest data point. And we also have 1, 2, 3, 4, 5, 6, 7, 8 boxes. And that we get 3.75 grams per box. And we'll round to 4. So each box is worth 4 grams. So that'll be 4, 8, 12, 16, 20, 24, 28, and 32. So now we're about ready. So we have our appropriate scale, and we're going to be able to fit every single point. Let's just make sure. Do I have any points above 32 in my mass? Nope, my highest point is 30. And do I have any volumes over 16? Nope, my highest volume is 12. So now I'm good. Let's make sure my units and labels are correct. So I have volume, milliliters on my x-axis, mass in grams on my y-axis. Good. Now I'm ready to plot my points. Let's take each point individually and check them off. So if I have a volume of 2, my mass is 5. So let's go here and find on my x-axis, my volume axis, in this case it means something. We'll have 2. And then we'll go up to our mass and see, well, you could even, sometimes you can make, if you have a bigger graph, it might be easier, but it's okay to just do a little bit of estimation here, you know? So right in the middle of 4 and 8 would be 6. So 5 would be a quarter of the way up that line. So there's going to be a point right there. Our next point we have here is 4 milliliters. So 4 milliliters has a mass of 10, so we'll go down to find 4 milliliters, and then we'll put that right here where 10 would be, right in the middle of 8 and 12 on that y-axis. Check that point off. 6 and 12. Oh, sorry, 6 and 15. Now that's going to be closer up to the 16. 10 and 25. That's going to be right. The 25 is going to be a quarter of the way up from the 24. And lastly, we have 12 and 30. 30 is going to be halfway in between. So now we have a nice set of data graph. I do want to ask this question: is 0, 0 appropriate all the time? You need to think about this and consider the nature of the data that you're doing. Now, in this case, if 0 mass has 0 volume. So yes, in this case, we do plot point 0, 0. Not all the time, and I'll write 0 down there as well. So now I'm going to do my line of best fit. Now, this is a direct relationship, so we know we are going to use our line of best fit. We know if we have more volume, we're also going to increase our mass. So, yes, we're going to do a line of best fit here, and what you want to do is you want to use a ruler, and that will help you do your line of best fit, and that's just the point that, the line that best represents this set of data. So you want to it doesn't necessarily have to go through all the points, but it's the one that minimizes the distance between all the points in the line of best fit. Sometimes the line of best fit might not even go through any of the points, but in this case, I have a pretty good set of data, and it does, so let's do my line of best fit starting at 0, 0 and going all the way through. So, this is a great example of a graph, and we're going to be doing this a lot throughout the year, so it is important, and you're going to do it in math as well.